So thank you, Peter, for this introduction. Thank you for leading oneM2M up until now. We gave you hard time over the last couple of years. Now it's my turn, and I told my wife I will be losing more hair in the meantime. So I had a look at the participants to this meeting. There are roughly 60 people who I know. They are familiar with oneM2M. There are 200 people that I would like to get to know. We have 3 days to do that, but if we don't have a chance to do that, here is my email address. Drop me a message and I will be glad to chat with you. So my term starts next week. I left this slide on purpose. I think Peter presented very well our organization, but I wanted to tell you a little bit more about this. We are a bunch of passionate engineers. We had a meeting in Busan, South Korea, 4 weeks ago, and I met with a guy who was busy with the implementation of oneM2M. He wanted to go back Friday evening to start aligning his implementation with oneM2M specification. It's not a joke, it's reality. We believe that we cover the full value chain for M2M and IoT. We have the security companies, the smart card companies, we have the device manufacturer, the chipset vendors, the system integrators, we have service providers, IT, we have university, and we have even some startups. So we believe that we have the right stakeholders who will help us in this journey. So we would like to, our work is about the common service layer for machine to machine. I will tell you a little bit more about this common service layer. We have a bunch of technical reports and technical specifications. All of them are publicly available. So I will tell you a little bit more about this. So what's the service layer? The service layer is a software layer. It sits between the M2M applications and the communication hardware and software, which are providing the data transport. It's on top of IP, even though we have some exceptions. For instance, we use triggering based on SMS in certain cases. It provides the functions that M2M applications across different industry segments. We have some preference to use the word industry segment as opposed to verticals. We have been speaking to some of those industry segments, and they consider people like myself to be a vertical for them, for instance, the energy. Those functions are exposed to applications via IT-friendly APIs. I think this is the most important part of our work, IT-friendly APIs. We want to make sure that you develop your M2M application not in months, not in weeks. We want to make sure you develop those applications in days. And we believe we have the foundation for that work. And last but not least, we believe that we have the foundation to provide distributed intelligence. We don't impose anything in terms of where you put the intelligence of your system. It could be in the cloud applications, it could be in gateways, it could be in devices or any intermediate points. So the way we work, we started with use cases coming from the different industry segments. That led to a set of requirements which we believe are in common between different use cases. Architecture and API, and we are recently starting a test and interop working group. So examples of use cases: automotive, home, energy, e-health. If you look at the requirements out of those use cases, you will clearly see that there are common requirements to all those use cases. And this is what's making the value proposition for oneM2M valid. So in terms of architecture, API, and protocols, again, we use IP-based communications. we came to the conclusion that RESTful APIs are the way to go because they are really IT friendly. We want to make sure that the people who are starting a company or the garage developers are able to develop on top of our platforms. In terms of protocols, I think the gentleman from ABI Research said a few words about this. We are not going to be religious on protocols. We came to the conclusion that several industry segments have their own protocols, and they want to stick to that. For instance, XMPP is used for the energy. We see a lot of developments around co-op. HTTP being used in several applications. So we are agnostic to protocols because everything is modeled as resources. The way you generate the data which is stored under resources, or the way you consume the data which is stored under resources, is actually independent from the way we manage those resources. Further down the road, we will add a very, very important piece of work. This is something we are passionate about it. We have been discussing about it, and it's really time to transform this passion into a strategy. And this is about adding semantic support to our data. So this is the extra step that will allow us to claim to be IoT or having IoT specifications. So right now we store the data in raw format, but we have already some studies which allow us to build the ontology and the semantic support for our specifications for smart appliances, for automotive, etc. Last but not least are the test and interop. So we are starting an activity here. It's a sign of maturity for our specification. We also think that there will be an increasingly important role for open source. We are aware of at least 3 open source specifications or implementations or ongoing implementations that support oneM2M activity. One of them being in Eclipse Foundation. It's called oneM2M. The second one is in Linux Foundation. It's under approval right now. And there is a third one announced yesterday, actually, by South Korea Telecom. This gentleman here will be telling you a little bit more about it. So, now, what you have on the left-hand side is what we call the vertical M2M application model. This is the model where you have a big application that implements the application business logic, but it also implements all the M2M functions that are needed to interact with the network, to perform device management, etc. At the bottom of the figure, you have devices, running applications connected eventually with via a local network, and there is a gateway which allows you to go from the local network to the wide area network. What you have in the right-hand side of the figure is the value proposition of oneM2M. So what we suggest is if you group all the functions which are useful to all those M2M applications in a common service layer. You put that in a distributed manner in the cloud, in the gateways, in the devices, and you expose those functions to applications by means of APIs. You will go from point-to-point communications to multi-point communications, because all of a sudden I will be able to share data between applications eventually coming from different industry segments, subject, of course, to access right and permissions according to privacy principles. So we really think that this architecture based on service layers, eventually we will have different service layers interconnected with each other, one deployed by a service provider, another one deployed, for instance, by an energy company, Schneider, for instance, connected to each other will be the foundation for the Internet of Things. Now, the only remaining piece of this is the notion of things. So things are here. It could be any article in the supermarket. It could be any device which is a sensor device. it may or may not have communication capability. If it's an article in the supermarket, then the device, the M2M device, will be the scanner to scan that object in the supermarket. Now, what M2M allows us to do is to have representation of those things in the service layer. They could be linked to the applications. And further down the road, we will add the semantic support for those representations of the things. So, a few words about the common service functions, which are the functions we have identified for the initial release to be part of the common service layer. Of course, when you switch on a device, you have some piece of software, an application which wants to register. You want to provide the basic security mechanisms. Here we have came to the conclusion there is no single security mechanism fits all. There are different security requirements for different industry segments. The security working group did actually a wonderful job in terms of figuring out what will be the toolbox to provide security, and it's really up to the implementation to make use of that toolbox. Group management. Assume that I have smart meters in the Nice Côte d'Azur area, or whatever, in the Nice area, and I want to send a piece of configuration information to all those smart meters. I want to avoid sending that information multiple times by the cloud application. I want to be able to write it once, and it's up to the service layer to get this piece of data all the way to all those smart meters. It will make use of the network. It will make use of any trigger function available at the network, and it will allow me to not bother about this, because as an application developer, I want to focus on my business logic for the application. We manage the data. All the data are stored under resources. Resources are created, updated, deleted, or retrieved, but we have a subscription and notification framework which allows me to get notification whenever the data is available for me to consume, for instance. Device management. We have some use cases where the devices are installed for a period of 30 years. This is the case, for instance, for utility smart meters. So if you install a device for 30 years, you don't expect that device to run the same piece of software over its lifetime. So device management is the ability to configure the device, but also to make software and firmware upgrades on the device, upgrade the security algorithm or the security keys. So it's a very, very important piece of information. For that part, we have decided to make use of whatever exists from BBF and OMA protocols. Location. If you have fleet tracking or fleet management applications, you want to provide location, and we allow for different kind of locations. Some of them are based on GPS, or we can leverage the network location as well. I think Peter spoke about the value proposition and why things matter, but if I have to pick one or two of those value propositions, I think with the framework that we have developed in oneM2M, we have more partnering choices and opportunities for M2M and IoT among the different industry stakeholders. We strongly believe that we can reduce time to market because the application will be much, much thinner, and they will focus on the business logic of the application as opposed to the communication framework, which is actually outsourced to the service layer. With this in mind, one of the conclusions is oneM2M is IoT ready. When I so I was listening to the presentation from ABI Research. He says that IoT is about multi-point, horizontal platforms, openness, and allows for experimentation. We think we are ready, IoT ready, because we have all those capabilities. We believe that the missing blocks comes in the next step for oneM2M, and that's about semantic support in order to allow reasoning based on the data which is stored under the service platform. Technical specifications. We have requirements, functional architecture. And as I said before, we have several protocol bindings because there are different industries which use different protocols, and we respect that. We take that as a requirement, and we provide different bindings for different protocols. Same thing for device management. We use OMA. Those of you who are familiar with OMA, there is OMA DM 1.3, 2.0, and lightweight M2M. We acknowledge all of that. We developed the data model for that. There is one thing which is important about device management when it comes to M2M. So the device in M2M environment has a piece of software which is eventually owned by the application service provider. It has a library, and it has a communication module. So those different parts could be managed by eventually 2 or 3 entities. So we expose device management all the way to the applications, which is really new compared to previous work, for instance, in BBF or OMA. And of course, we have the security mechanism. We have developed the toolbox to make security work in eventually all the scenarios for machine-to-machine communications. One example, it's an e-health scenario. I believe you have a demonstration very, very close to this. It's more on the home domain, but they have also an e-health part of it. So what we have in this figure, we have a set of devices connected to a gateway, which is here, which is connected to cellular network. The data is shipped to the M2M platform. And then we have an eHealth web application which provides different view of the data pertaining to the eHealth. There could be one view relevant to the patient, another view relevant for the doctor, etc. So just a recap of our design principles. We are IP-based. We use RESTful resources. Resources are representations of devices, applications, and things. We have the ability to link those resources together. So for instance, I can link the things which are pertaining to me in that representation over the service layer. Distributed intelligence, we see people talking about cloud computing, fog computing. All of those are allowed in our specifications. You will see me putting the word reuse several times because we don't want to reinvent the wheel. We reuse whatever is available and recognized by the industry. We think we are future-proof because our architecture is ready to support the ontology and to have some semantic support, and that allows the migration path towards IoT. We don't mandate any implementations. You can use relational database, you can use NoSQL database. That's not at all mandated by our specifications. So this is probably a techie slide. And if we take back the example we presented earlier for the eHealth, our architecture is based on applications, which are here shown as AEs. We have network service entity, which is whatever services provided by the network. It could be location, it could be device triggering. And in between, we add what we call the CSE, the common service entity, which is the piece of software that sits between the application and the network. So at the left-hand side here, you have potentially what we call the application service node. It could be a device within the home environment. It runs an application entity. It makes use of the CSE, which is For instance, a DLL library in a Windows operating system. It's a library, if you will. We have this MCA reference point, which is exposing the functionality of the service layer to the application. And the CSE will make use of the underlying network by means of the MCN reference point. A few words about this MCN reference points. We don't really specify this MCN reference point. We reuse or endorse whatever reference points available in the underlying network specification. It could be based on 3GPP. It could be some OMA for specification, for instance, for location. And those CSEs talk to each other in a horizontal fashion to exchange the data on behalf of the application entities. Some example, which could be mapped to the smart metering industry. So what you have on the left-hand side could be a smart meter. It has a measurement application doing smart metering. It's connected to a local connectivity network. Again, if we bring back the smart metering, it could be a power line communication network, and the M2M gateway could actually be a concentrator, which is in the utility domain or the utility substation for those of you who are familiar with those utility terms. So the gateway will connect to a 3G network. And then at the right-hand side of the figure, we have the server-side service platform, which we call the INCSE, which is exposing functionality to cloud applications, so backend applications, for instance, for utility systems. And what we will do is, first of all, we have bootstrapping. We perform device management in order to provision the additional credentials and for applications. We do registration. We do application authentication. And then assume that the device generates a first piece of measurement. We write that first piece of measurement in the gateway CSE. That gateway CSE has an aggregation software, piece of software, which is the aggregation and format conversion. So the MNCSE will notify the aggregation application about the availability of a first piece of data. It gets consumed. It's not necessarily deleted. It gets consumed. It could stay there. We have a second piece of data, ship it up to the aggregation application, and at some point in time, this aggregation application will decide to generate one single piece of data out of all those measurements. So it will ask its library, its MNCSE, to ship it upstream to the server-side service layer. Here, we could have what we call the delivery handling mechanism. So delivery handling is about efficient use of the network based on application policy and network policy. So if I know that this data could wait to be shipped for 3 hours, and if I know in 1 hour that the network will provide me with better tariffs, then I will delay the shipping of that data until I get that better tariff. And again, the same mechanism happens. The notification is sent to the cloud application. Now, in terms of deployment, this INCSE could be deployed by an M2M service provider. The M2M customer application, so the backend application of the utility, could be deployed by the M2M application provider. And in between, there will be a secure VPN connection, for instance, between the data center of the M2M service provider on the left-hand side and the data center of the M2M application provider on the right-hand side. Resources. So again, information in the service layer is stored under the resources. Remember my previous speech about, or my previous discussion about the things, and we represent the things in the service layer, be it in the device, the gateway, or the cloud. We use resources in order to store that. So resources are both about the data that you are sending upstream, but you could have metadata which is pertaining to the semantic description of that data. Resources are linked with each other. We access resource by means of uniform resource identifiers, which are essentially URIs or URLs. And the good thing about the resources, once again, we don't care which protocol generated those resources. They could be generated by HTTP, consumed by co-op, or vice versa. It does not matter at all. And when we consume the resources, the other good thing, we can request in what format we consume those resources. The server will be doing the translation for you. As an example, we have here an HTTP example. I could be doing, how am I doing on time?
4 minutes.
4 minutes, that's good. So I could making this request to get a temperature measurement. The host provides the host where the actual resource is located. The from is the identity of the entity which is requesting that resource. But then I could provide what format I'm accepting. So in this case, I'm accepting a JSON format. In other cases, it could be XML. And what you will see that the answer will come back in JSON format. For those who are familiar with JSON, it could have been XML. We support both. Security. Again, the challenge with M2M security is that there is no single size fits all. Francois is our working group chair for security. He comes from a security specialist company. So we came to the conclusion that we have to address this in a toolbox manner. Because we have large variety of scenarios. So we had to provide secure communications, but authentication options are multiple. It could be depending on the use case or on the scenario or on the industry segments. We had to deal with issues such as any device in any deployment, which means that we had to develop solutions for remote provisioning. And last but not least, remember, we are in a multi-point environment. It's not one device generating data to one application. We want to make sure that we provide the foundation for the Internet of Things, and that means multi-points, which means whenever I generate a piece of data, it could actually be consumed by multiple entities subject to access right and permission. And this is what we call the access control policy. It has an entity dimension who can consume the data, but it could have a context dimension. At what point in time, which geographical location.
2 minute warning.
Skipping this one. So, I'm almost done. So, interworking. We are aware that there are several organizations working on, for instance, peer-to-peer inland communications. AllJoin being one of them. We have some interaction with this organization by means of joint members. LG Electronics is helping us on this particular piece of work. And we are starting a framework where oneM2M could actually integrate or interwork with the work being done in AllJoin. This is one example. We have several examples of interworking. We are working on interworking with 3GPP. And there is a bunch of those in the pipe because we believe in our role to federate multiple of those technologies. Now, because I'm the future TP starting next week, I had to put something on the next steps. So this is not the end of the story. We have more in the pipe. If I have to pick one, I will pick big data enablement. Because this is something we have been talking about, and it's time to make it in the specifications. So we are trying to figure out how to build the semantic support for oneM2M. This has multiple facets, one of them building the ontologies. for the industry segments. For instance, smart appliances. We will also be looking to all other enablers for big data enablement for IoT environments, things like query language evolutions, reasoning. This is, again, I will put a disclaimer, this is not firmly committed by the organization, but we have been discussing this over the last TP, and I see a reasonable chance for some or several of those features to make it to the next release of the specification. Thank you very much. I'm on time.